Welcome back to another lecture from organic chemistry. In this lecture, I'm going to go through enantiomers, and also I will show you how to find whether we are dealing with R or S configurations. And enantiomers are molecules that they are mirror image of each other, but they are not superimposable. Okay, so when you put them on the top of each other, they will not match. Okay, they will not match each other. They look the same. Okay, they look mirror image of each other, but they are not superimposable. Okay, for example, in this case, if we treat this one as a mirror, and I'm going to say I have an ethyl group that is close to it. And so I'm going to show that ethyl group here. I have an ethyl. Okay, and then I will have chlorine. And this is going to be a position of the chlorine. And then we will have a methyl group. Methyl group is going to be somewhere here. Okay, and so let's write the chlorine here. And that's the chlorine. And these two molecules are mirror image of each other, but if you try to put them on the top of each other, they're not going to match. And this is the this is the proof for it. As you see, the ethyl group here is on the left side, while on this molecule is going to be on the right side. Again, let's give it a try. Okay, so if I highlight this one and try to move this molecule, I want you to follow the ethyl groups. And so I will put the carbon top of each other. Chlorines are matching. Everything it looks fine, except the ethyl and methyl. And the highlighted substituent, and one of them is on the left side, the second is going to be on the right side. And that highlighted substituent is the ethyl, okay, ethyl group. So I'm going to say these two are a mirror image of each other, but not superimposable, because that's the reason we call them enantiomers. There are other ways to show whether those molecules are enantiomers or not. It's easier than keep drawing the molecules, and I want to actually go to that direction. Okay, and so as you see, these two example, and they said we are dealing with enantiomers, okay, but they did not. Okay, they did not change. Okay, they did not flip technically the backbone. Backbone, it looks the same. The only thing that they changed the wedge here. The one is pointing to us. The left one is pointing to us. The second one is back of the molecule. Okay, back of the molecule. So the first one is pointing to us. And I'm going to say this one is pointing to us, and the second one is back of the plane. Is pointing technically, or you can say it's back of the plane. This is another way to show that we are dealing with exactly the same formula, same connectivity. Only difference between them, the substituent in opposite directions. And we use, we call them, here the dash and wedges, dashes and wedges, and to show that we are dealing with substituent, that they are pointing in different directions. And again, here I have a stereocenter. This is my stereocenter. I can see another stereocenter is there. These two are enantiomers. How do I know they are enantiomers? Because they change position of the methyl group. As you see, the methyl groups, and one of them is pointing to us, and the second is back. And how about this? Do we have enantiomers? And about those two. Okay. And do we have enantiomers here? And for the last example, I'm gonna say no. The reason for it, you have two identical substituents attached to carbon. So you don't have a stereocenter, okay? There is no stereocenter, okay? And because it's not, we don't have a stereocenter, so I'm going to say this molecule is not chiral. So technically, that molecule is going to be achiral or non-chiral, okay? We have an easy way to show the enantiomers instead of, again, just simply switching position of the substituent, and we use R and S. R for whenever the rotation is clockwise, and S for counterclockwise. Okay, and how do I assign whether that one molecule it has R or S configuration? And I'm gonna start with this. Okay, so we have these three molecules, and the points that I'm gonna highlight here. That's the stereocenter here. And again, we do have a stereocenter here, and that's another stereocenter. Okay, I want to know whether I'm dealing with R or S configurations. And I want you to, actually to be sensitive on the fourth position, okay? The fourth position on any of this molecule. Okay, the fourth position on the first molecule is pointing to you, okay, pointing to you. So we need to have a substituent to make carbon octet, and the last substituent is going to be hydrogen. And that hydrogen has to be back of the molecule, okay? And second one. And the second one, we have OH is pointing to us. OH is back of the molecule. Forgive me. OH is back of the molecule. That means the last substituent, it will be pointing to us, and that's going to be hydrogen, and I'm going to fill in that wedge. Okay. And again, here we have hydrogen that is back of the molecule. And for the second one, we have hydrogen that is pointing to us. Okay. that hydrogen is going to be pointing to us. Based on position of hydrogen, you will determine technically whether you're dealing with S or R configuration. Why I say based on hydrogen? Because in most of the cases, hydrogen is going to have the lowest priority. Okay, let's go and review all possible situation or scenarios. First one, I have a stereocenter. Okay, I do have a stereocenter, and where is hydrogen? Hydrogen is going to be back of the molecule. Okay, the way you're going to determine technically configuration of any molecule, you will look to the molecule in a way that the lowest priority will be back of the molecule. Okay, so you'll look to the molecule from any side that you want in a way that the lowest priority it will be back of the molecule. The first priority it will be for oxygen. Why? Because of the atomic number. The second priority it will be for this carbon. Why that carbon? Why do I say that one is 2? That carbon, this carbon is attached to one carbon here, so it's attached to a carbon and 2 hydrogen. But how about this carbon? That carbon is attached to 3 hydrogens. So we have carbon, hydrogen, hydrogen versus hydrogen, hydrogen, hydrogen. Which one is going to get higher priority? The one on the right side. So this is going to be 3. Now follow this order. Of course, I forgot to say this one. This hydrogen is going to be the 4th priority. Okay. Now follow those numbers or look to the molecule in a way that the lowest priority will be back of the molecule. So I'm going to look for it from this side. And I will follow order of this molecule. Order is showing me this is clockwise. And because it's a clockwise, the configuration is going to be R. Okay, the configuration is going to be R. And we are going to use R and S configuration to differentiate the enantiomers from each other. Okay, so when hydrogen or the lowest priority back of the molecule, just simply assign the priority based on atomic number and see whether it's a clockwise or counterclockwise. If it's a clockwise, it will be R. If it's counterclockwise, it will be S. Second option, hydrogen or the 4th priority is pointing to us. So it's facing to us. And so as you see here, OH is back of the molecule. That means I'm going to have hydrogen, and that hydrogen will be facing to us. Okay. So I have hydrogen facing to us. Now let's assign the priority. This is going to be number 1. Again, this is number 2. That one is number 3. And hydrogen is going to be number 4. Okay, for a second, I'm going to close my eyes on that hydrogen. So we said number 1 is OH. This is number 2, and that one is number 3. Okay, follow the numbers. It says this is a clockwise, so it's supposed to be R. It's supposed to be R. Be careful. It's supposed to be R. I did not care about hydrogen. I'm going to ask myself, where is hydrogen? Okay, where is hydrogen? Hydrogen is pointing to us. Because hydrogen is pointing to us, you have to flip the configuration and say the original molecule must have S configuration. Original molecule must have S configuration. Okay, let's prove it. Okay, let's prove this one. We're going to look to the molecule from this side, from the back of the molecule. So because hydrogen is facing to us, we're going to go back of the molecule and look to the molecule. And when you look to the molecule from back side, okay, so OH is going to be on the top when you look to it. Okay, so I'm looking to the molecule. OH is on the top. What else? I see a methyl on my right hand. Methyl on my right hand. And I see an ethyl group on the left hand. So this one is ethyl group. Okay, let's give them priority. This is 1, ethyl, it will be number 2, and methyl, it will be number 3. Now let's follow the order. When you follow the order, this is counterclockwise, so the configuration is going to be S. Okay, again, let's review whatever I said. So we said, you're going to assign the order. Okay, order says that like is supposed to be R. Okay, but then you will ask yourself, where is hydrogen? If hydrogen is facing to you, just simply flip the configuration and say the original molecule must have S configuration. So the original molecule, it has S configuration. Another way, go and look to the molecule from a side that hydrogen is going to be far from you. Okay, so I'm going to look to the molecule from the back. Why from the back? Because hydrogen is pointing to us. So we're going to look to it from the back of the molecule. If hydrogen is here, you're going to look to the molecule from this side because hydrogen is pointing to you. And the third case is when hydrogen is inside the plane, okay, inside the screen. Then what do I need to do? Okay, you have a couple of options, okay, to go after this one. Okay, where is hydrogen? I say hydrogen is inside the plane and on the left hand. Okay, I can say this. This is number 1, that's number 2, this one is number 3, and hydrogen is number 4. It's inside the plane. I'm going to put my eyes here, and I will look to the molecule from this direction. When I look to the molecule from that direction, I see OH up, and then I see ethyl on the left side and methyl on the right side. And so this is going to be OH, this is methyl, and this one is ethyl. Okay, 1, 2, 3. Okay, this is going to be S configuration. Okay, how about the second one? Second one, we put hydrogen on the right side. Okay, we go 1, 2, 3, 4. Now look to the molecule in a way that hydrogen will be far from you. I'm going to look to the molecule from this direction. So, okay, I will look to that stereocenter, okay, from technically from the left side. When I look from the left side, I see OH on the top, but then I see ethyl on my right hand and methyl on left hand. So again, OH, this is ethyl, and that one is going to be methyl. We go 1, 2, and 3. Okay, this time rotation is clockwise, so I'm going to say I'm dealing with R configuration. Okay, so if you have H on the plane, okay, now try to look to the molecule from a side that hydrogen will be far from you. Okay, if hydrogen is on the plane and is on the left side of the molecule, then you're going to look it from the right side. If hydrogen is on the right side and on the plane, you're going to look to the molecule from left side. Okay, and you look it in a way. And so then hydrogen is going to be technically, far from you. That's one way to do it. Okay, that's one way to do it. Okay, another way to do it is, okay, when you assign the priority, you will switch position of the fourth one with the third one. Okay. Oh, forgive me. You will switch position of hydrogen with whatever that is back of the molecule, not number 3. It doesn't need to be number 3. Okay, again. So I assign the priority. I'm going to find the lowest priority, number 4, and I'm going to switch it with priority with the substituent that is back of the molecule. I don't care what's the substituent, okay? Whether it's number 1 or number 3, okay? It can be any number except 4. Okay. So we're going to switch those two. If you switch them, this is going to happen. So hydrogen will go back of the molecule. I'm going to get hydrogen here, so I will write this is going to be hydrogen. Hydrogen, it will have the 4th priority, and methyl, it will show up here. This is going to be methyl. It will be CH3. Okay, so hydrogen used to be there, and methyl used to be here. Sorry, forgive me. Hydrogen used to be in front. Now we move hydrogen back, and we brought the methyl on the plane. Okay, now if you try to assign the configuration until here, okay, you will see that the rotation is going to be clockwise. Okay. Rotation is a clockwise, and but if you look to the molecule from this side and try to assign the configuration for the starting molecule, the configuration for it, you have OH on the top, methyl on the left, right hand, and ethyl on the left hand, and this is going to give you okay, 1, 2 here, and 3. That's supposed to be S, but we got R. Okay, why did I get R for the second molecule? Okay, I started here from 1. I flipped 2 substituent. New one is R. Okay, the new one is R. Okay, now why this one is R and how this one is going to help me? What's the purpose of flipping these 2 substituent? Okay, story is this: we have hydrogen on the plane. Okay, we wanna figure the configuration. One way is to put your eyes somewhere and look at the molecule in a way that hydrogen will be far from you. That's one option. If you have a hard time with it, how about this? Do your best to move hydrogen back of the plane. Okay, back of the plane. So you're going to say, I have this molecule, so assign the priority for it, and I'm going to switch position of hydrogen with methyl. Why? Because it happened that methyl is back of the molecule. So I moved it back. Now that I moved it back, hydrogen is back of the molecule, so I can easily assign the configuration. What's the configuration? It's R. Whatever you see as a configuration, opposite of this configuration is the right configuration for the starting molecule. Because you flipped position of 2 substituents. If you change, okay, so if you change position of 2 groups or 2 substituents on the stereocenter, okay, in that case, R configuration, it will turn to S, or S configuration, it will go to it will turn to R. So the configuration, it will be opposite. Okay, the configuration, it will be opposite. Okay, and I can approve this one for you. Okay, so I have the same structure. Okay, and right now I go 1, 2, 3, 4. Okay, and if you try to assign the configuration for it, and you put your eyes here, you will see that the configuration for it is going to be 1, 2, 3. This is going to be S. Okay, let's approve it. Okay, I'm going to change position of hydrogen with methyl. So I will have hydrogen here, methyl is there, and OH remain the same position. So OH is there. And then what else? I have the ethyl, and this is the ethyl group. Okay, you can write it as OH or HO, it doesn't matter really. Okay, to keep it the same, I can write it as that way. Okay, next, try to assign the configuration for number 2. Okay, number 2, hydrogen is back of the plane. And so you say 1, this is going to be 2, and this one 3. And configuration until now is a clockwise, so it will be R. So from S, we move to R. Why? Because we change position of 2 substituents. We change position of hydrogen, okay, hydrogen with methyl. Okay, now keep those two, their position. So don't change hydrogen, methyl. We're going to keep hydrogen and methyl. So hydrogen is going to be here, and methyl is going to be there. Now change position of OH with the ethyl. OH with the ethyl. So OH is going to go down here, and the ethyl, it will go there. That's going to be ethyl. Now, okay, now assign the priority. Again, this is going to be number 1, that's number 2, and this one, number 3. And where's hydrogen, the 4th one, is back of the molecule. Good news, it's back of the molecule, so we don't need to care, we don't need to bother about it. And so this is going to be counterclockwise. It will be S. Okay, so I got S again. What does it mean? It means number 1 is equal to number 3. Why? Why number 1 is exactly equal to number 3? Because I switched position of 2 substituent 2 times. 2 times. If you do it 1 time, the configuration from S, it will turn to R. Okay, and if you do it 2nd time, R must turn to opposite configuration. So R is going to turn to S, and because I did it twice, 2 times, I changed position of the substituent. I'm going to get the original configuration. So 1st time we flipped, the configuration was there, and this is going to be the 2nd time. Okay, and this is the proof. This is the proof that your configuration is going to be S. The configuration of the starting molecule is going to be S. And number 3 is showing you that the configuration of the starting molecule is S.